Hello everyone and welcome to another C++ beginners video tutorial. In this tutorial I wanted to talk about structs and show you how to create one and use one in C++. So let's go ahead and get started by creating our project. We'll call this one Structs. Okay, and create our main file. Call this one main, and then go ahead and include IOStream to output things to the console, as well as our main function. There we go. Okay, so structs in C++ are a way for you to contain a bunch of different type variables or the same type of variables together in one object. And it's pretty useful when you have multiple variables that relate to each other in some form, and you want to keep them together so that you don't have a bunch of variables, like 10 or 15 variables, that you have to look through to find the one that you want. For example, something like a vector where it's made out of an x and y floats. If you want to create a variable for, let's say, a position, for example, and you have float x position and float y position, you can have something like this. But if you have multiple objects that need multiple x's and y positions, it will get really messy by saying float x position 2 and float y position 2, and so on and so forth. So it gets very messy really fast doing it this way. So structs give us a way to actually put all these variables, the variables that relate to each other together, so that we can use them as one big object. For example, we can do a struct vector2, just like we did before. And just keep in mind that a struct always has to end in a semicolon between the curly brackets. And we can do something like float x and float y. And as you can see, it gives us a data structure here that contains an x and y for a vector2. So we can use that for positions, we can use it for velocities, speeds, whatever we want to use it for, acceleration, anything. So now that we have our vector2, how would we go at creating one of these? So first thing we can do is say something like vector2 and the name of our struct. Let's say position. Now to change the values of each variable in a struct, as you can see here, it just says float x and y, and by default these are public, so you can access them from outside this struct. For example, you can say position or pos.x equals 10.0 f, and pos.y is equal to, let's say, 20.0 f. And finally, let's print it out. We can say std cout. We'll put something like a bracket, position x, position.x. As you can see, you have to use, oh, no comma there. You have to use the dot notation to actually get access to the variables inside the struct. So it's your struct name, dot, and the variable name that you're trying to access inside that struct. And let's say we put a comma here. And finally, our position.y and another bracket, and then std and l. And we'll do an std_cn.get to keep our console open. Okay, now that we have that set up, we can try to run it. And as you can see, it's 10, 20, 10 on the x, 20 on the y. And this gives us access to a new type of variable that you can use for many different things, consisting of multiple default variables. Of course, you can go even deeper into that and create a struct that contains variables of other structs and so on. But we'll keep this simple by using the default data types. Okay, so now that we have this, what else can we do with structs? Structs are pretty useful because they can contain their own functions inside that struct. For example, we can make a constructor for that struct, like we can say vector2 and put 2 brackets there. And let's say it takes an int underscore x and int underscore y. So when we're trying to create a constructor is used in a struct whenever we're trying to create a new struct. For example, we can do something like vector2 position is going to be equal to a vector2 of 10.0f and 20.0f. And that will, once we put here what we want to do with these values, so for example, our x is going to be equal to our underscore x, and y is going to be equal to our underscore y. And this just says when this constructor is called to create a new struct, take an x and y value and use these x and y values to assign it to our x and y values in here. So these will be our values for that. Also, you can give them default values. For example, you can say, I want the x by default to be 0.0f and my y by default to be 0.0f. So if you don't give it any parameters whatsoever, our struct would be created with 0.0 and 0.0. Otherwise, you can give it whatever values that you want, and these values will be assigned here instead. Okay, so now that we have this, we don't need this anymore because we don't need to assign it manually to start the values off. If we try to run our program again, and as you can see, we get the same values, 10 and 20, because we initialized our struct using these 2 values. Okay, so what else can we do in functions inside these structs? So a vector can have a magnitude, and we can make a function that gives us our magnitude. For example, void, or let's make our magnitude a float because we want to get it back. It would be mag. So this function, we wanted to give us the magnitude of this vector2 that we just created. So we have access to our x's and y's, which is fine. So the next thing that we need to do is to find the magnitude for the x and the y for that whole vector. Of course, the magnitude is going to be equal to, so we're returning x times x plus y times y, and all that will be square root. So the square root of x times x plus y times y. And that should give us the magnitude for our struct. So let's give it an easier value so that we can get something that we can figure out that if it's right or wrong right away. So let's say it's a 3.0f and 4.0f, so that we can get a 5. So it's a 3, 4, 5 triangle. That will be a 5.0 magnitude. So let's see if that works. std cout. So we want to output the magnitude of our vector, which will be position dot, and of course to call a function it's exactly as if you're calling a variable. You would say magnitude and give it the parameters. For this one we have nothing, so empty brackets, and finally std end line. There we go. Okay, so let's go back and see now in our program if this works. And our magnitude is 5, as you can see here. One more simple thing that we can do to make it easier for us to output these things is to make a toString or print for our vector2. We want a function that in our vector2 that can print the value of that vector2 to the console. So we can do something like void print. So our print function, we wanted to print out what the vector 2 looks like. And for that, we will do std cout. And exactly like what we were doing right here. So that will be position.x position.y, and finally a closed bracket, and then std end line, not self, and line, and that would be it. Not position now, x and y, because we have access to our x and y right here. So now that we are printing out our x's and y's for this vector, we can say, instead of this whole line, we can say position.print, and that will give us a print of our vector. So if we go ahead and run it, and as you can see, 3, 4, and a magnitude of 5. If we change this to, let's say, 10.0 f and 10.0 f and run it, 10 and 10, and our magnitude is 14.1421. So this is a quick rundown of how structs work in C++. As you can see, you can have a constructor for it. Of course, you can have multiple constructors. So if we want to do something like, if we don't want this to be a default, for example, and we want just an empty one, we can say vector2, and then we want just an empty constructor. So if we want an empty constructor in here, we can just say x equals 0.0f and y equals 0.0f. If you don't say anything, the default constructor will be called, which is this one. So if you don't run anything, it will call this one. So if we run here, as you can see, 0 and 0, and the magnitude is 0. And if you give it any values, which will be equal to a vector 2 of 3 and 4, it will instead go to this one. And you can have as many of these constructors as you need. So this is a quick rundown of how structs work in C++. I really hope this video helped. If you have any feedback or comments or questions, please leave them below. Thank you very much for watching, and I will see you in the next video.